Okay, students, we're now looking at exercise 14.6, question 7. We can see that we have a triangle there. It's an isosceles triangle, ABC, and we're told that lengths AB is equal to AC. And we're also told that P and Q are the midpoints of AB and AC respectively. Now, just from that, we would then know that therefore AP equals PB and that AQ would equal QC. However, because AB equals AC, it means those four lengths, AP, PB, AQ and QC, must all be equal to each other, which would therefore mean that PB equals QC. Now we need to write this down in our answer. So we start off with our answer for part A, and we can say that AB equals AC and that is given. We can then go on to say that AP equals, so we can then say that AP is equal to PB, which equals AQ, which equals QC, and that's because P and Q are the midpoints of equal sides. Therefore, we can see, and it's already stated there, that PB is equal to QC. So that's proving that PB equals QC. Now, to look at part B, we want to prove that PC is equal to BQ. Now, to be able to do this, we're going to use congruent triangles, but we have to look at which triangles PC and QB are in. Now, PC is a side in triangle PBC, and QB is a side in triangle QCB. So if we can prove that triangle PBC and triangle QCB are congruent, we can then say that PC and QB are corresponding sides of congruent triangles. So that's the approach that we're going to take. So we want to be saying which triangles we're talking about. So we're talking about in triangle PBC and triangle QCB. We can now say that PB equals QC. That's given above. Now, we can see that the two triangles that we're talking about are actually overlapping. Something that I like to do is to actually draw those triangles separate, and I'll just bring them in here, make them a little bit smaller. So that's the first triangle, and I'll just bring the second triangle in. I'm just bringing that in now. And all right, they're not looking exactly the same, but you get the idea. So we've got PBC and QCB. I know I haven't labelled them there, but we know that PB equals QC. So that was proven above. I'll just bring in those sides. So that's P at the top. Actually, no, I won't bring that in because it's causing a bit of a mess here. So, but you know which sides are which. We also can see that BC, so we've proved that PB equals QC. We can also see that BC is a common side. It's along the bottom. So we can say that BC is a common side. And we're looking for one last piece of information in those triangles. Now, because ABC is an isosceles triangle, therefore angle ABC there, or I'm actually showing it here on this triangle here, ABC or PBC in this triangle, equals angle ACB here, which is this angle here, angle QCB. So we can say that now. So we can say that, therefore, angle ABC, which is that one, or this one here, is equal to angle ACB, because they are base angles of isosceles triangle, given that AB equals AC. Now we need to say AB equals AC because that's our explanation as to why the triangle is isosceles. So now we have our three pieces of information. We can now therefore say that triangle PBC is congruent to triangle QCB, but let's see what we've got. We had that side, we had the base, and we had the angle in between. So it looks like it's going to be, the reason is side angle side. So triangle PBC is congruent to triangle QCB. Reason, side angle side. Now that the two triangles are congruent, we can now therefore say that PC equals QB, matching sides of congruent triangles. So the trickiest thing about this would be to know which two triangles to prove are congruent. What you've got to do is look at the question that they're asking you, prove that PC equals BQ, and find the two triangles that those two sides lie in. Okay, if you do that, and also using the bit from part 1 that PB was equal to QC, it's obvious that you're going to use these two triangles down the bottom.